Find the w dt if w is equal to x squared plus z e to the power y plus sine xz, and x is equal to t, y is equal to t squared, and z is equal to t to the power 3. Now, you can see that we have three functions, x, y, and z, that are being fused into one function called w. Okay? That means we are going to use still chain rule, okay, for multivariable function, and here's how it's going to look. So we have dw dt. Okay, this will be equal to, we have partial derivative of w with respect to x first, then multiplied by, we differentiate this x now with respect to t, plus we differentiate w with respect to y, then we differentiate y with respect to what? T, plus we differentiate the function w with respect to z, then we differentiate z with respect to t. So that's what we are going to do. Now, I want you to pay particular attention here. So now let's find those. What is the derivative of w with respect to x? So x, the rest, this one will disappear because there's no x. Here we have there. So along here we'll be having 2x, okay, plus, if I differentiate sine xz, what do I get? I'm going to differentiate xz. What's going to remain is z. So z will come in front. But what's the derivative of sine? It's cos. So it will be xz. Okay? So we are done with the first part. Now, what is the x dt? This part here is just 1. Plus, differentiating w with respect to y, this will go. Even this one will go because there's no y, there's no y. So we have this guy here. Alright? So differentiating this guy here with respect to y. Differentiate y is just 1. Get the concept, then you multiply by the base. So this will just still give you z e to the power y. Alright, of which we are multiplying by the derivative of y with respect to t, which will be 2t, plus we go to derivative of w with respect to z. This one will go, this will remain. So what do we have? Differentiating this with respect to z, what do we get? Look at it first. If you differentiate this with respect to z, z will go. So you are going to have what? E to the power y is what is going to remain with. Plus, differentiating sine xz with respect to z, x will come out. Then you're going to have cos xz. We still have dz dt, we are here, which will give us what? 3t squared. And see, here we are done. It's just a matter of simplifying this. So let's simplify. So we have 2x plus z cos xz, okay, then plus there's a 2 here, so the 2 can come in front. We have z, then ey, okay, but there's a t, so don't forget the t. I'll just put it here. Okay, we're done there. So we come here now. Here we have, wow, so there's a 3 there, so we have 3t squared, which can multiply ey, e to the power y. Then plus, we still have this part here, which can be multiplied by 3t squared z cos xz. Alright, now we know what x is, we know what y is. It's just a matter of replacing now. So let's just do the replacement. So we are here, we are replacing, eh? We know that x is just t, so here we're just going to have t, 2t. Plus, we know that z is just t to the power 3. So we put t to the power 3 here. Cos, what is x? X is just t. X is t, right? Z is t to the power 3. So we have t multiplied by t to the power 3, which gives us t to the power 4. So here we just put t to the power 4 plus 2z, okay, is t to the power 3, okay. But there's also another t here, which will give us t to the power 4. Then we've got e. What is y? Y is t squared, like that. Plus, here we are here 3. So we have t, this would just remain the same, and e, then t squared, like that. Plus, we are here 3. All right, t. What is x is here, right? So sorry, what is z? Z is t to the power 3. Okay, yeah, z is t to the power 3. Where is it? Where is it? Here, yes. So we got t to the power 4 there. Sorry, not 4, because we've got 3. So we have 3t squared, which is here. I'm not going to write it, but we also have got z. All right, is it z or x? Oh, sorry, it's x. Here we wrote x, but here we forgot to write x. Sorry, it's x here. Yeah, and x is t. So t, okay, that would be 3 here. Then we have xz, or we know is to the power 4, right? Can this be subtracted or added? Yes, you can. So dw with respect to t, what do we get now? 2t, this is t, like that. Okay, this one will remain the same. So the 2t will remain the same. Okay. Okay. All right. The cos and the cos here, they can be added, right? Because this is 3t to the power 3, t to the power 3, cos t4, cos. All right. So those can be added to give us 4 t3 cos t4. This and this can be added. Then here we are here. This we cannot add because t squared here and here is t to the power 4. But there's something that we can do to them. All right, we can take out e to the power t squared. All right, if we take that out, we end up remaining with t to the power 4. Here will remain 3 to the power 4, and here will remain 3t squared plus 3t squared. Then we can take e t squared. Vamos. Partial differentiation of multivariable functions. You're welcome.